Hey everyone, in this video we're going to learn how to solve quadratic equations by completing the square. Before getting into this video, make sure you're confident on completing the square and solving absolute value equations, as we're going to tie those two concepts together. To start us off, solve for x, and the equation is x minus 3 quantity squared minus 16 equals 0. So we can solve this in two ways. The first way we'll just talk about, which would be to square x minus 3, so we'd have x squared minus 6x plus 9 minus 16 equals 0, combine like terms, and factor. But we already know how to solve a quadratic using that method. So is there another way that we can solve this equation? Well, what if we add 16 to both sides? So we'd have x minus 3 quantity squared equals 16. Well, now this looks like a quadratic equation that we solved by creating an absolute value equation. And the way we did that was to take the square root of both sides here. The square root of x minus 3 squared became the absolute value of x minus 3. The square root of 16 is 4. And then we created two smaller equations. So x minus 3 equals 4. And the negation of x minus 3 equals 4. So here we can add 3 to both sides, so we'd have x equals 7. Here we can distribute out the negative 1. Negative x plus 3 equals 4. Subtract 3 from both sides, negative x equals 1. Divide both sides by negative 1, x equals negative 1. So our solution set is negative 1 or 7. Well, looking back at this expression, that looks like the expressions we get after we complete the square. So in this case, it seems they completed the square for us, and then we solved by creating an absolute value equation. So in the examples that are going to come, I'd imagine that we're going to have to complete the square on our own and then finish the problem off in this way. So we're going to have two steps to solve each equation. Now, just as extra practice, if you want to try the factoring method, you should get negative 1 and 7 as your answers. That'd be a great way to review an old technique. So our directions solve each equation by completing the square. All answers should be in simplest form. So we have x squared plus 2x minus 8 equals 0 as our first equation. So just as with any quadratic, I always want to equal to 0 before I start. Okay, because whether I'm using factoring or completing the square, we'll stay consistent with that idea of setting a quadratic equal to 0 to solve. Now, since we're completing the square, we're going to put a parentheses around x squared plus 2x. So we have x squared plus 2x plus something minus 8 minus something equals 0. I normally don't put this minus blank spot, but because we have an equation now, I don't want to forget about it and write the equals 0 too close to the minus 8. Okay, first we want to create a perfect square trinomial. So we're going to take half of 2, which is 1, square it, which is 1. But if we're adding 1, to keep everything in balance, we have to subtract 1. So if we factor our perfect square trinomial, we would get x plus 1 squared, and then minus 8 minus 1 is minus 9 equals 0. So now that we have our expression, x plus 1 quantity squared minus 9 set equal to 0, we can solve in the same way we did in the previous slide. So we'll start by adding 9 to both sides. So x plus 1 squared equals 9. We'll take the square root of both sides. So that gives us the absolute value of x plus 1 equals 3. And now we can set up two smaller equations. So x plus 1 equals 3, or the negation of x plus 1 equals 3. X plus 1 equals 3, we can subtract 1 from both sides, so x equals 2. Here we can distribute out that negative 1. So negative x minus 1 equals 3. Add 1 to both sides, so negative x equals 4. Divide by negative 1, so x equals negative 4. So our solution set is negative 4 or positive 2. And with any of these problems, we can always take our solution set, plug it back into the original equation, and see that it is true. So just running through negative 4, we have negative 4 squared, which is 16, 2 times negative 4, which is negative 8, so 16 minus 8 is in fact 0. Same thing with 2, 2 squared is 4, 2 times 2 is 4, 4 plus 4 minus 8 is also 0. Okay, but this problem, we had to first complete the square, then we create an absolute value equation, and we solved. Our next equation, x squared minus 10x plus 5 equals 80. So we're solving a quadratic equation, so the first thing we want to do is set it equal to 0. So x squared minus 10x minus 75 equals 0. Subtracting 80 from both sides of the equation. Now that we have our quadratic equal to 0, put parentheses around x squared minus 10x, since we're completing the square. So that means we have x squared minus 10x plus something, minus 75 minus something. Don't want to forget about that before we put the equal 0. Okay, so what value completes the square? So we take half of negative 10, which is negative 5. We square it, we get 25. So we have to subtract 25 to keep everything in balance. So factoring x squared minus 10x plus 25, we have x minus 5 squared. And then minus 100 equals 0. So we can add 100 to both sides. So x minus 5 squared equals 100. Take the square root of both sides. We have the absolute value of x minus 5 equals 10. And then we get x minus 5 equals 10, or the negation of x minus 5 equals 10. So here we can add 5 to both sides of the equation. We get x equals 15. In this case, instead of distributing, I'll divide by negative 1, which was our other technique there. So x minus 5 equals negative 10. Add 5 to both sides, x equals negative 5. So our solution set is negative 5 or 15. And again, we can plug either of those values in to the original equation to see that the equation is true. Make sure we didn't make a careless mistake along the way. Next up, we have x squared plus 20x plus 70 equals 4x plus 18. So first thing we want to do, we're solving a quadratic, so let's set it equal to 0. So it's going to give us x squared, subtract 4x from both sides, so plus 16x. Subtract 18 from both sides, so plus 52 equals 0. Now we're completing the square, so I'll put x squared plus 16x inside of parentheses. So x squared plus 16x plus something. And then plus 52 minus something equals 0. Okay, so what value completes the square? So half of 16 is 8. So plus 64. And then we'll subtract 64 to keep things balanced. So factoring x squared plus 16x plus 64, we'd have x plus 8 squared. And then plus 52 minus 64, so that's minus 12 equals 0. Okay, so now we add 12 to both sides, so x plus 8 squared equals 12. We're going to take the square root of both sides. So this gives us the absolute value of x plus 8 equals, well, 12 is not a perfect square. So we have to put this in simplest radical form. So if we remember, square root of 12 can be expressed as the square root of 4 times the square root of 3, which is 2 times the square root of 3. So 2 square root of 3. Okay, so we have x plus 8 equals 2 square root of 3. And we have the negation of x plus 8 equals 2 square root of 3. So here we can subtract 8 from both sides, so x equals negative 8 plus 2 square root of 3. Since I have a square root on the other side, I'm going to divide both sides by negative 1 as my first step. So x plus 8 equals negative 2 rad 3. Subtracting 8 from both sides, x equals negative 8 minus 2 rad 3. So our solution set is negative 8 plus 2 rad 3, or negative 8 minus 2 rad 3. Now these look like answers we could have gotten with the quadratic formula. So the nice thing about completing the square is it works in every case. If we think about factoring, the quadratic had to be factorable. If it wasn't, we then solved with the quadratic formula, and the quadratic formula always worked. Now, from this example, we see that completing the square will also always work. Whether it's factorable or not factorable, if we're using the technique of completing the square, we'll always be able to get a solution if there is one. Alright, now we have x minus 6 times x plus 1 equals 22 minus x. So they want us to do a little bit of work here. So first we'll start by distributing out, so x times x times 1, so x squared plus x, then distribute out the negative 6, minus 6x minus 6 equals 22 minus x. So we have x squared minus 5x minus 6 equals 22 minus x. So we have a quadratic. We want it equal to 0 before we start solving. So I'll add x to both sides, so x squared minus 4x, and subtract 22, so minus 28 equals 0. Not a very good 0. Okay, now we're using the technique of completing the square, so we'll put a set of parentheses around x squared minus 4x. So x squared minus 4x plus something minus 28 minus something equals 0. Okay, so half of negative 4 is negative 2. Squared is 4, so we have to subtract 4 as well. So we have x minus 2 squared minus 32 equals 0. So add 32 to both sides, so x minus 2 squared equals 32. Now we're going to take the square root of both sides of our equation. Now 32 is not a perfect square, so we can express that as the square root of 16 times the square root of 2, which is 4 times the square root of 2. So we have the absolute value of x minus 2 equals 4 rad 2. And now we're going to create our two equations from the absolute value equation. So x minus 2 equals 4 times the square root of 2, or the negation of x minus 2 equals 4 times the square root of 2. Okay, so here we're going to add 2 to both sides, so x equals 2 plus 4 square root of 2. Because I have a square root on the other side, I'm going to start by dividing by negative 1. I find that easiest. So x minus 2 equals the negation of 4 rad 2. So adding 2 to both sides, x equals 2 minus 4 rad 2. So our solution set, 2 plus 4 rad 2, 2 minus 4 rad 2. If you want to express that as 2 plus or minus 4 rad 2, that would be perfectly acceptable as well. Okay, so this one was a little bit more work. We had to start by distributing everything out, even if we were going to solve by factoring. That's the step that we would have to take. We can see from our answers that it wouldn't have been factorable, so basically we would have had two choices, quadratic formula or completing the square. Now in this case, they told us we had to use completing the square, but just talk through our options if they just had said to solve. Factoring wouldn't have worked. We could have chosen this technique or gone back and used quadratic formula. Next up, 3x squared plus 16x plus 20 equals x squared minus 12. Okay, first thing we want to do is set it equal to 0. We're solving a quadratic. We want to stay consistent with that first step. So subtracting x squared from both sides, we'd have 2x squared plus 16x. Add 12 to both sides, so plus 32 equals 0. So we're solving by completing the square, so we're going to put a set of parentheses around 2x squared plus 16x. So we have 2x squared plus 16x plus, whoa, almost made a mistake there. What's the first thing we have to do if we're completing the square when x squared has a coefficient? We have to factor that coefficient out. So it's 2 times x squared plus 8x plus something plus 32 minus something equals 0. Okay, so this is the first one in this video that we saw with a coefficient of 2. So we have to remember how our technique changes. Our first step is to factor that coefficient out, so we just have x squared, and then we can proceed as we have. So what value completes the square here? So half of 8 is 4, squared is 16. Now we're not really subtracting 16 though. We have this 2 in front. If we were to distribute it back out, would turn this into a 32. So we have to subtract by 32. Okay, so that means 2 times x plus 4 squared, and then that's just 0, equals 0. Okay, so we can divide both sides by 2, so x plus 4 squared equals 0. So we can take the square root of both sides. So we have the absolute value of x plus 4 equals 0. So either x plus 4 equals 0, or the negation of x plus 4 equals 0. So here we have x equals negative 4. Here we'll distribute out the negative 1. So negative x minus 4 equals 0. Negative x equals 4. X equals negative 4. So in both equations we get the same solution, which makes sense. There should only be one value that gives us 0 in an absolute value equation. So our solution set is just negative 4. Find the x-intercepts of the following quadratic function by completing the square. Okay, so first, this is a reminder of how we find x-intercepts. And that is to set y equal to 0. Now in this case, they use function notation instead of y, so f of x. But they are one and the same. So we're going to start by setting 2x squared minus x minus 3 equals to 0. Now at this point, we would try solving this, right? So we could factor, we could use quadratic formula, or completing the square now. So now we have that third technique, but they specified for us. Complete the square, so we don't have a choice. Okay, so we're going to put a set of parentheses around 2x squared minus x. So we're going to start by factoring out the 2. So x squared minus 1/2 x plus something minus 3 minus something equals 0. Okay, we're dealing with fractions here because when we factored that 2 out, the coefficient of x became 1/2. So we're going to take half of that, which is 1/4. If you're not sure, just 1/2 of 1/2 is 1/4, just to see that written out. And it's 1/2 of negative 1/2, so negative 1/4, just to be completely correct. So squaring that, we have 1/16. Remember now we have to distribute the 2 in, so we're really adding 1/8, so we're subtracting 1/8 out here. Okay, so this is going to be 2 times x minus 1/4 squared. With the fractions, remember it's sometimes difficult to factor, but this value, the half of the coefficient of x, will be the value in the factor. Now I need a common denominator here, so 3 becomes 24 over 8. So that's minus 25 over 8 equals 0. Okay, so we can add 25 over 8 to both sides, so 2 times x minus 1/4 squared equals 25 over 8. Now just like in the last example, we can't take the square root yet. We have this 2 here in front that we have to move to the other side. We want the square term just by itself. So I can multiply both sides of this equation by 1/2. So that's going to give me x minus 1/4 squared equals 25 over 16. So we can take the square root of both sides of our equation. Okay, so we have the absolute value of x minus 1/4 equals, well, 25 over 16 is a perfect square. It's 5 over 4. So that actually works out nicely for us. So that means x minus 1/4 equals 5 over 4, or the negation of x minus 1/4 equals 5 over 4. So here we can add 1/4 to both sides, so that would be x equals 6 over 4, which remember, simplest form would be 3 over 2. And then here, we can divide both sides by -1, or we could distribute. Choice is yours. X minus 1/4 equals -5 over 4. And then we can add 1/4 to both sides, so that would be -4 over 4, which is x equals -1. So our solutions, remember, we're not just looking for the x values. They said find the x-intercepts. So the x-intercepts of our function are 3 over 2 comma 0 and -1 comma 0. Right? X-intercepts, we want to write them as points. Perfect. Okay, so through all of these examples, we can see how we're tying in completing the square and absolute value equations. This is a good one to end with because not only did we get fractions, which we hadn't in any previous example, we had that leading coefficient. Okay, before you take the square root of both sides of the equation, you want to make sure that the squared term is by itself. Right? So we added the 25 over 8 over first, then we had to get rid of the 2 that was the coefficient, so we multiplied by 1/2. Okay, so these are the more challenging types of equations we can see, but as long as we follow the same steps and we isolate the square term and create the absolute value equation, it's really no more difficult than any of the other questions that we look at. The only other thing that we didn't see that I think you understand, but I just want to make sure, if you're ever solving and you wind up with something like x plus 1 squared equals -4, think about that for a second. We're saying if we square a value, we get a negative number. If that ever happens, that equation is going to have no solution. Okay, so I just want to make sure we're aware of that if it ever comes up in our solving. Now it's up to you to practice with this technique. The more you do, the better you're going to get. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.